Welcome back, AI developers. Today, we are diving into one of the most critical aspects of building agentic AI, defining tools. Specifically, we will master the tool decorator and Pydantic schemas to give your large language models robust, error-free, real-world capabilities. Let's get started. Let's begin by defining what a tool actually is in the context of large language models. By default, an LLM is a phenomenal reasoning engine, but it is trapped in a box. It cannot browse the internet, it cannot query your proprietary SQL database, and it certainly cannot click buttons in your application. It relies entirely on the static data it was trained on. This is where tools come in. A tool is a specific function or capability that you expose to the LLM, acting as its hands and eyes in the real world. Why is this so crucial? Because without tools, agents cannot take action. When we define a tool, we are creating a bridge between the non-deterministic natural language environment of the LLM and the deterministic programmatic environment of your backend systems. How does it work? The LLM doesn't execute the code itself. Instead, it generates a structured JSON payload, indicating its intent to use a specific tool and providing the necessary arguments. Your framework parses this intent, executes the Python code, and feeds the observation back to the model. Take a look at the flowchart on your screen. This visualizes the fundamental architecture of LLM tool usage. On the left, we have the large language model, which serves as the brain of our operation. When a user submits a complex query, the LLM analyzes it and realizes it needs external information. It generates a tool call request, mapped to the top arrow. This request is sent to the Python tool, representing our code, whether that's a calculator, a web scraper, or a database query script. The tool executes deterministically in your secure backend environment. Once execution is complete, the tool packages the results and sends them back along the bottom arrow as observation data. The LLM then consumes this new observation data, integrating it into its reasoning context to formulate a final answer. Moving on to implementation, how do we actually create these tools? The most elegant and common method is using the tool decorator. The tool decorator is a wrapper that instantly converts a standard Python function into a LangChain compatible tool. Why do we love using this decorator? Because it strips away massive amounts of boilerplate code. Before decorators, developers had to manually write extensive JSON schemas to define OpenAPI tool specifications. Now, you simply place the decorator above your function definition. As shown in the bullet points, you just import tool from LangChain core.tools and place it above a function like multiply. The deep dive here is understanding how LangChain knows what to tell the LLM. The decorator automatically inspects your Python type hints, like specifying that variable is a float, and it reads your function's docstring. It uses this metadata to build the instruction manual that the LLM will follow. This diagram illustrates the magic that happens under the hood when you apply the tool decorator. You start at the top with a standard, vanilla Python function. The moment you apply the decorator, it transforms into a specialized LangChain tool object. Notice how it branches out into three critical components that the LLM needs. First, the name is automatically inferred from your Python function's name. Second, the description is dynamically extracted directly from your Python docstring. And third, the argument schema is built seamlessly from your Python type hints. This automated pipeline ensures your LLM always has the exact specifications required to format its requests without you writing a single line of JSON. Let's peel back another layer and examine auto schema generation. As senior developers, we must remember that large language models do not read or execute Python code. They operate entirely on structured text, primarily JSON. When we use the tool decorator, LangChain performs an on-the-fly translation, converting our Python signature into a strict OpenAPI JSON schema. Why is this critical? Because this schema is passed to the LLM during the API call, effectively serving as the tool's instruction manual. This brings us to the docstring rule. In the context of AI agents, your function's docstring is no longer just documentation for other programmers. It literally becomes the system prompt for the LLM. If your docstring is vague, the LLM will hallucinate arguments and fail. Once the schema is auto-generated, we use methods like .bindTools to attach it to our model, enabling the LLM to output perfectly formatted JSON matching your function parameters. This sequence diagram represents the runtime execution flow of our auto-generated schema. On the left, the LLM decides to take action and sends its intent along with JSON arguments to the LangChain framework. LangChain acts as our robust middleware. It takes that JSON, maps it to the expected schema, and executes the actual Python tool in your environment. The Python tool does the heavy lifting and returns a raw result, perhaps a database object or a string. Finally, LangChain takes that raw Python result, formats it back into an observation message, and delivers it to the LLM. This perfectly bridges the gap between text generation and code execution. While the basic @tool decorator is great, enterprise applications demand absolute reliability. Basic Python type hints like string or integer are often insufficient. What if your database query tool requires a date specifically formatted as ISO 8601? A simple string type hint won't prevent the LLM from outputting next Tuesday. This is where Pydantic schemas come into play to enforce strict data contracts. Pydantic is an industry-standard data validation library. By creating a class that inherits from Pydantic's base model, we can define complex, nested argument structures. The true superpower here is Pydantic's field class. By using field description equals, we can inject highly specific instructions for each individual parameter. We aren't just telling the LLM, give me a string, we are saying, give me a 10-digit alphanumeric customer ID. Furthermore, if the LLM makes a mistake and violates this contract, Pydantic immediately throws a validation error, halting execution before bad data corrupts your backend. Let's look at this class diagram to visualize the Pydantic integration. At the top, we have the Pydantic base model, which provides all the underlying validation logic. We extend this to create our custom customer query args class. Inside, we define our specific properties, such as a customer ID string and an ISO formatted date string. Crucially, as noted at the bottom, we attach field descriptions to these properties. These descriptions are surgically extracted by LangChain and injected directly into the LLM's prompt. This guarantees that the model fully understands the micro-level constraints of your backend database API. Let's translate theory into code. How do we combine the ease of the @tool decorator with the rigorous validation of Pydantic? The solution is the arg schema parameter. Looking at the code snippet on the slide, we first define our Pydantic class, calcargs, extending base model. We declare the expression variable and use the field method to describe exactly what the math expression should look like. Next, we apply the @tool decorator to our actual Python function, but we pass arg schema equals calcargs into the decorator itself. This explicitly overrides LangChain's basic inference and forces it to use your strict Pydantic model for the OpenAPI spec. This is a game changer for enterprise resilience. In advanced deployments, you can even enable handle tool error equals true. When Pydantic inevitably catches an LLM hallucinating a bad parameter, this setting catches the crash and sends the exact validation error back to the LLM, prompting it to self-correct its mistake autonomously. This flow visually summarizes our code implementation. We start on the left with our robust Pydantic base model. Instead of relying on guesswork, this model injects a strict, typed schema directly into the @tool decorator using the arg schema argument. The decorator then wraps around our core function logic the actual Python code doing the work. Finally, this combined powerhouse results in a resilient LLM tool execution environment. The data contract is guaranteed before a single line of your operational code is ever allowed to run. Let's apply this to a highly critical, real-time use case, an intelligent refund agent. Imagine deploying an AI to assist customer support. It has a tool that hits your backend financial API to issue refunds. The danger here is immense. If the LLM hallucinates an account ID or misformats a currency amount, it could accidentally refund the wrong user or issue an excessive payout. To secure this, we build an execute refund args Pydantic schema. We enforce strict rules. The account ID field must match a 12-digit regex, and the refund amount must be a positive float. In action, the LLM reads a customer's vague email and attempts to trigger the tool. But because our Pydantic wall is in place, it intercepts the payload. If the LLM extracted a 10-digit ID by mistake, Pydantic instantly throws a validation error. The transaction is blocked. The agent sees the error, realizes its mistake, and smoothly asks the human user to clarify their 12-digit account number. Total financial security is maintained. Follow the transaction flow of our intelligent refund agent. The user request hits the LLM orchestrator, which attempts to formulate a refund command. The flow hits the daemon decision node, our Pydantic schema validator. This is our impenetrable firewall. If the data is mathematically and structurally valid, it proceeds to execute the backend API. However, if there is an invalid ID, it takes the failure path. It blocks the execution and returns a descriptive error directly to the LLM. The LLM then reevaluates and communicates with the user to get the correct data. This prevents catastrophic backend failures. To wrap up our deep dive into defining tools, I want to leave you with 3 golden best practices. First, write exceptional docstrings. Stop treating them as mere developer comments. They are highly engineered prompts. Include specific examples of when the LLM should use the tool, and, equally important, when it should not use it. Second, keep your tools laser-focused. Do not create God tools with 20 optional parameters. If a tool is too complex, the LLM will get confused. Build single-purpose, atomic tools. Third, wholeheartedly embrace Pydantic. If you are building for production, ARG schema is not optional. It is the only way to enforce strict data contracts and leverage automated error recovery. Mastering the combination of tool decorators and Pydantic schemas is what truly transitions your application from a passive chatbot into an active, autonomous workforce. Thank you for joining me in this masterclass. I invite all learners to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep. At Quicktechie, we offer extensive Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides to accelerate your AI engineering career. See you next time. This final mind map summarizes our pathway to success. The foundation of our best practices branches out into writing clear docstrings, enforcing strict Pydantic fields, and utilizing built-in error handling mechanisms. When you combine these 3 pillars, they converge to create highly reliable agents. These are the systems that can be trusted to run your enterprise workflows securely and autonomously. Thank you again and keep building.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment. Or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.